After World War I, a certain country sought to promote atheism through scientific reasoning. They hoped their entire population would break free from religion and belief systems. So they invited 3 scholars to deliver public speeches in the town square. The first was an astronomer. He said, "I have used a telescope to observe the universe for more than 20 years, yet I have never once seen a god. Therefore, I am certain that deities do not exist." The second was a medical doctor. He declared, "I have performed autopsies on hundreds of bodies and examined each organ carefully, but I have never found a place where the soul could reside." The third was a female scholar, a theorist. She calmly stepped onto the stage and stated, "Death is like a lamp going out. Once it's out, it's over. There is absolutely no such thing as heaven or hell to pass judgment. I have read books from both East and West, but found no written record mentioning such things." When the 3 scholars finished speaking, they were met with thunderous applause from the crowd. But does this mean gods truly do not exist? Why can't we see them? Is it because they aren't real? Or is it because we simply haven't yet developed the capacity to recognize their presence? Science continues to advance and evolve. Humanity's understanding of the universe and the supernatural has become increasingly clear and accurate. But the question remains, is the science we currently possess enough to prove the existence of God? A famous American theoretical physicist eventually used string theory to support the existence of God. Can you believe that? Today, let's take a look through the lens of science to explore why we still cannot see the divine. Michio Kaku is an American theoretical physicist of Japanese descent. He is also a futurist and a passionate science communicator. Currently, he is a professor of theoretical physics at the City College of New York. Anyone with a love for physics likely knows his name. When Michio Kaku was just 8 years old, a great scientist passed away. That day, his teacher walked into the classroom with a somber expression and said to the students, "Just now, the greatest scientist of our time has passed away." That same day, all the newspapers featured a photo of one man. On that desk, there lay an unfinished manuscript. The owner of that desk was none other than the great scientist the teacher had spoken of, Albert Einstein. The headline on the newspaper read, "I will never forget this manuscript, the greatest legacy of the greatest man of our time." 8-year-old Michio Kaku asked himself, why couldn't he finish the manuscript? Was it just a really hard homework problem? If so, why didn't he ask his mom for help? Why couldn't he solve it? Right then and there, young Michio made a life-changing decision. He would find out exactly what that unsolvable problem was. From that moment on, Michio fell in love with physics and resolved to follow in Einstein's footsteps. Not long after, he became fascinated with a television series called Flash Gordon. Every Saturday, he would sit in front of the TV and never missed an episode. He deeply admired the characters: Flash Gordon, Dr. Zarkov, Dale Arden, and the futuristic scientific gadgets that captivated the audience's imagination. Spaceships, rockets, invisible shields, laser guns, and even cities in the sky, Michio Kaku was completely captivated. It was the flying hero Flash Gordon who opened up an entirely new future world in his imagination. Michio's young mind was always filled with wild thoughts. Could we one day walk through walls? Could we build spaceships faster than the speed of light? Might we read minds, become invisible, move objects with our thoughts, or even teleport ourselves into space in the blink of an eye? Could time travel, laser weapons, force fields, and parallel universes one day be real? These questions deeply fascinated Michio and sparked immense excitement in him. Even while engrossed in television, he never forgot Einstein's unfinished manuscript. In high school, for a science fair project, Michio visited the Westinghouse Company. There he collected over 400 pounds, more than 180 kilograms, of scrap metal, transformers, and steel parts. Then, in his mother's garage, he built his own particle accelerator. That Christmas, Michio wrapped over 22 miles of copper wire around his school's football field, an extraordinary feat for a high school student. As a high school student, Michio Kaku built his own electron accelerator, capable of reaching a power of 2.3 million electron volts. To operate it, he needed 6,000 watts of electricity, the same amount used by his entire household. His machine could even generate a magnetic field 20,000 times stronger than Earth's magnetic field. Michio's goal was to create enough power to generate gamma rays and antimatter. This ambitious science project earned him a spot at the National Science Fair, which ultimately led to a scholarship from Harvard University. There, he began fulfilling his dream of becoming a physicist and following in Einstein's footsteps. Years later, Michio came to understand that the unsolved problem Einstein left behind was the theory of everything, a formula meant to unify all the fundamental forces in the universe. This theory, much like Einstein's iconic equation E equals mc squared, could potentially answer some of the biggest questions in astrophysics and cosmology. Why do stars shine? Why do galaxies emit light? Why does Earth have energy? Today, Michio Kaku is one of the leading figures behind string theory, one of the most significant scientific efforts to decode the fundamental laws of the universe. Today, Michio Kaku is not only a physicist specializing in theoretical and high-energy physics, but also an environmental scholar and internationally renowned theoretical scientist. He has always upheld Einstein's spirit, continually seeking to uncover the fundamental principles of the universe. The string theory that Kaku introduced is, in fact, expressed through a formula only 1 inch long. Yet that single-inch equation might very well be the first key to unlocking the universe's greatest mysteries. So, how did Michio Kaku manage to use string theory to explain the secrets of the cosmos? Even the greatest scientists have wrestled with deep philosophical dilemmas. For example, Einstein once said, "God does not play dice," and Kaku was no exception. Although born in the United States, Kaku grew up in both the US and Japan. While he was fascinated by physics, he also read a wide variety of books, from mythologies and legends to religious texts from both Eastern and Western traditions. This diverse exposure shattered his one-dimensional thinking and allowed him to view the world from multiple perspectives, not only from a scientific lens, but also through spiritual and philosophical ones. A worldview that is both profound and expansive. The universe we live in still holds countless mysteries beyond our understanding. During his research, Michio Kaku discovered that in ancient Greek mythology, Zeus, the king of the gods, could control objects around him using pure thought. With just a single intention, he could turn particles from the void into tangible matter. The goddess Venus possessed a flawless, eternal body, and the sun god Apollo rode a chariot that could move across the sky. So if the gods of Greek mythology were real, why can't we see them? From this, Michio Kaku arrived at a profound realization. The world is multidimensional, and so is the universe. Humans live in a three-dimensional space, and because of that limitation, we are unable to perceive life forms that exist in higher dimensional realms. But why can't we see those beings? And why is it even more difficult to take our physical bodies into those other dimensions? How can this concept be proven in a way that people can easily understand? While living in Japan, Michio went on a scenic tour. During that trip, a surprising moment of inspiration struck him. In Japan, May 5th is known as Boys' Day. On this day, families with sons hold a special tradition. On this day, across Japan, families hang carp-shaped flags in front of their homes, symbolizing hopes that their sons will grow up strong, successful, and wise. This tradition began during the Edo period and is closely tied to the Chinese legend of the carp leaping over the Dragon Gate. A scholar from the Song dynasty, Lu Tian, once wrote a book that was passed down for generations, titled Biya Loves Fish. In it, he recorded the saying, "The carp leaps over the dragon gate, and if it succeeds, it becomes a dragon. Only the carp has this fate." According to legend, dragons have 81 scales, representing yang, while the carp has 36 scales, representing yin. It is said that carp can live for 1,000 years. In ancient tales, immortals were often depicted riding either dragons or carp, soaring over mountains and lakes. Thus, carp came to be considered the fish most similar to dragons. Through selective breeding, the carp eventually became what we now know as koi fish, a prized ornamental species in Japanese culture. In contrast, the common goldfish we see today was actually bred from wild crucian carp. In Japan, koi culture is deeply cherished. One unique feature is that people don't just admire the fish's colors, they specifically enjoy observing the backs of the koi. That's why koi are often kept in shallow ponds, allowing people to admire their elegant, flowing beauty from above. If you enjoyed this video and found it helpful, don't forget to leave a comment, hit the like button, share with your friends, and subscribe to the channel so you won't miss any upcoming videos. Thank you so much. People often admire the intricate patterns on a koi fish's back and the graceful way it glides through the water. One day, while Michio Kaku and his wife were watching koi swim, he found himself staring at them deeply. And suddenly, in his mind, the image of the koi swimming began to transform, shifting from a two-dimensional scene into a vivid three-dimensional one. He thought, if I were that koi fish, living in a two-dimensional world within the pond, I would have no idea that, right above me in a three-dimensional world, there might be a higher being observing me. Then, one day, if that koi were to leap out of the water, it would enter a whole new three-dimensional world, a higher dimension of existence. From the koi's perspective, this upper world, where it could see people walking around in all directions, would be as surreal as humans imagining life on another planet. In that world, there's no water, no fins are needed, and yet, beings move freely and exist with ease. It would be a world that a koi fish simply couldn't comprehend. And after having experienced this higher dimension, if the koi returned to its pond and told its fellow fish, "Hey, I just left the water and saw this incredible kind of creature. It has 2 legs, 2 arms, and no fins," the koi fish exclaimed to its friends after returning from the other world. Now, guess what the other koi fish would say? They would certainly respond, "Are you crazy?" Likewise, if humans were somehow able to leap out of the three-dimensional world, wouldn't we also enter an entirely new realm, a higher dimension where gods exist, but that we humans currently cannot comprehend? Moving from 3 dimensions to multiple dimensions, from the perspective of theoretical physics, is undeniably difficult to grasp. But if we view it from the perspective of the koi's world, isn't it much easier to understand? 1 dimension, only length. 2 dimensions, a flat plane with length and width. 3 dimensions, a solid space with length, width, and height. Then what is the 4th dimension? It's a 3-dimensional space plus time. Therefore, the dimension of time is not the same as space-time, nor is it equivalent to the concept of a time-space continuum. In other words, whether you're a koi or a human, the limitations of your own biological nature restrict you to the space-time you exist in, and any truth that lies beyond that dimension we simply cannot see. Naturally, then, we do not believe. But just because we can't see something, does that really mean it doesn't exist? Just because something is unseen doesn't mean it doesn't exist. That's why Michio Kaku, following in the footsteps of Blue Brother, was determined to find evidence proving the existence of the non-existent. And it was precisely while observing the koi fish that he eventually discovered string theory. So then, what exactly is string theory? In modern physics, there are two major theories used to describe the universe. One is general relativity, and the other is quantum mechanics. General relativity describes the structure of the macro universe, the large-scale world. Meanwhile, quantum mechanics describes the structure of the micro world, the very small scale. In theory, descriptions of the macro and micro worlds should work together harmoniously. However, when scientists discuss the Big Bang, they find that the phenomenon of the singularity and the moment of the Big Bang belong both to the micro world and to the macro world. That's where the conflict between quantum mechanics and general relativity emerges. Their explanations for the four fundamental forces seem to contradict one another. So what are these four fundamental forces? In everyday life, we can observe the buoyant force of seawater on boats, the adhesive force of glue, the attraction and repulsion between magnets, in the micro world, between molecules or atoms, between atoms, electrons and atomic nuclei, between particles within the atomic nucleus, all involve forces of attraction or repulsion. Scientists have categorized these into four main types, called the fundamental forces of nature: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. When scientists discovered that the descriptions from quantum mechanics and general relativity of these four forces were in conflict, a new theory was needed, one that could unify these two disjointed theories and bring them into harmony. After nearly 100 years of research, scientists found that indeed, there is some kind of unification between general relativity and quantum mechanics, and that the two are continuously approaching each other. Many physics formulas, as a result, have disappeared. Of course, not because they no longer exist, but because they've been replaced by simpler formulas. At the final step, just as a complete unified integration was about to be achieved, string theory emerged. And Michio Kaku was one of the founders of string theory, aimed to resolve the contradiction between two incompatible theories to create a theory of everything that could describe the entire universe, including both the macro and micro worlds. One of the most famous hypotheses in string theory is that all particles are not point-like, but are tiny strands of energy, imperceptible to us. We can call them strings, vibrating in different ways. Just like violin strings, if they vibrate in different ways, they can produce different musical notes. Similarly, fundamental particles are formed by different vibrational states of the string. The mathematical equations of string theory require space to have 9 dimensions, plus one time dimension, a 10-dimensional space-time. Sounds a little abstract, doesn't it? So where does 10-dimensional space come from? If we stand on Earth and look at the moon, we see the moon moving in a circle. That's 2-dimensional motion. But if we look from the sun, we'll see Earth moving in a circle, while the moon is a helical circular motion, is essentially a 3-dimensional motion. If we were to observe from the center of the Milky Way, The Sun would be moving in a circular path, while Earth moves in a circular motion that follows a helical form. This type of motion is similar to how the Moon's motion appears when viewed from the Sun. And in the helical circular motion of the Moon, it also includes the helical circular motion of the Earth-Moon system. At this point, it becomes a six-dimensional motion. If we stood at the center of the universe and observed, the black hole at the center of the Milky Way would be seen moving in a circular path, while the Sun moves in a large, extended spiral, a helical motion. At this point, the Sun becomes the blue orbit in the image, while the Moon becomes the red orbit. The Moon's helical circular motion includes 2 layers of helical circular movement, making it a 9-dimensional motion. Adding 1 dimension of time, the 10-dimensional space is thus formed. In 1995, at the International String Theory Conference held at the University of Southern California, an American mathematical physicist, Edward Witten, was the first to propose that all string theories have a common origin. Thus, M-theory was born, and it unified all versions of string theory, elevating it to a higher level. M-theory suggests that the highest number of dimensions in the universe is 11. That is, the 9 spatial dimensions of string theory, once integrated with an additional spatial dimension through M-theory, become 10, and adding 1 time dimension makes 11. This is how the 11-dimensional universe is formed. If we shrink the universe down to the size of an atom, and then observe the motion of macroscopic celestial bodies, what we would see would be the vibrations of open and closed strings. For example, the movements of black holes and neutron stars become 2 types of open string vibrations. Meanwhile, the motion of the Sun, Earth, and Moon becomes closed string movements. In short, string theory claims that in the universe, there are no actual particles, only strings vibrating in space. Different particles are simply different vibrational modes of the strings. If you enjoyed this video and found it helpful, don't forget to leave a comment, hit the like button, share with your friends, and subscribe to the channel so you won't miss any upcoming videos. Thank you so much. In nature, all matter and energy can be explained by the splitting and joining of strings. Ultimately, these multidimensional worlds are all around us. Just like koi fish cannot leave their pond, we too cannot separate ourselves from the environment we are currently living in. Even if we manage to escape the pond, there is still a higher space-time outside and above it, and the collection of all worlds resembles a unified space-time. At this point, doesn't it sound familiar to everyone? That's right. It seems like there is a similar concept in Buddhist scriptures. Take a look. Space-time consists of spatial dimensions plus a time dimension. Doesn't that resemble the concept of heavenly realms mentioned in Buddhist teachings? In the Shurangama Sutra, Volume 4, there is a passage recorded as follows. The world forms the heavenly flow. Space defines direction. East, west, south, north, southeast, southwest, northeast, northwest, above, below. These form space. Past, future, and present. These form time. This shows that the world spoken of by the Buddha already included both spatial and temporal dimensions. The Shurangama Sutra, Brahmanet Sutra, and Genesis Sutra all speak about how the universe is structured. The Mount Sumeru world, described in Buddhist scriptures, corresponds to a solar system, and the Jambudvapa realm mentioned in the sutras refers to planet Earth. In the Genesis Sutra, it also mentions the concept of the 3,000 great thousand worlds. A group of 1,000 worlds is called a small thousand world. A group of 1,000 small thousand worlds is called a middle thousand world. A group of 1,000 middle thousand worlds is called a great thousand world. Small, middle, and great thousand worlds together are called the 3,000 great thousand world system. This is the world of one Buddha. roughly equivalent to the scale of one galaxy. In the universe, countless 3,000 great thousand worlds exist. In Buddhist texts, this is referred to as the 10 directions and dust-like worlds, Thap Puong Vitran the Gyoi. By now, you probably understand how different dimensions and spacetimes objectively exist, right? Because of differing dimensions and spacetimes, the beings that live within them are also different. The laws of physics are not the same either. This is perhaps exactly the scene, the prosperity within the 3,000 great thousand worlds described by the Buddha. Isn't this exactly what it means? That's why Michio Kaku once said, "All current physics textbooks are wrong. Every physics textbook on Earth says that the universe is primarily made up of atoms. Wrong." In the past 10 years, we've gradually discovered that the majority of the universe is actually dark. Young people need to go out and explore to uncover the secrets of dark matter and dark energy. Michio Kaku discovered that the great thinker, in the final years of his life, ultimately turned to religion. At the same time, he stated, "The understanding of God in religion is the highest form of science." This is completely reasonable, because during his own research into strings and string theory, he came to deeply realize that there exists a tremendous power behind it all, a force that causes strings to vibrate, which humanity still cannot comprehend or reach. Thus, he proposed the tachyon theory, a type of subatomic particle that travels faster than light, theoretically proposed as a hypothetical particle derived from the theory of relativity and moves at a speed faster than light, exceeding the speed of light, can tear apart the vacuum of space between matter or between particles in the universe. This allows all things to be unaffected by the surrounding universe. After conducting experiments on such particles, Michio Kaku made a truly captivating conclusion, proving the existence of God. He said, "We exist in a plan governed by rules that were created by a universal intelligence, not by random chance." And what is this universal intelligence that governs everything? Only God can provide the explanation. Michio Kaku believes that God is certainly a mathematician because the 10 and 11-dimensional spaces derived from string theory are not only superspace but also supersymmetry. From that emerged string theory, and then from it came supermathematics, superdifferential geometry, supersymmetry theory. All of these have fundamentally changed mathematics, because everything in string theory can be described using pure mathematics. Michio Kaku also said, "God is also a musician." When you come to understand the thoughts of God, you will realize his thoughts resemble countless vibrating string frequencies, each producing different particles that come together to form the universe. Those string vibrations resonate through the 11-dimensional superspace, creating harmonics, and from there, producing a magnificent cosmic symphony. That is where our life originates. This is the true shape of the universe. This is the mind of God. And what about you? What are your thoughts? Do you think that physics has finally revealed what we've long been wondering? That perhaps our bodies are existing in higher dimensions, far above, beyond what we can perceive? And could it be that life forms from higher realms are also observing us, just as we observe koi fish in a pond? We welcome you to share your thoughts in the comments section below the video. And that brings our sharing today to an end. If you found this video or any content on our Miss Ruby channel truly helpful, please consider sharing it with a friend so they can explore it too. Thank you so much, everyone. Goodbye, and see you again soon.